This video is about drawing clearly labelled force diagrams by identifying the number of separate objects in a system and describing the forces acting on them. So first of all, let's go through a definition. So a force is any interaction that, when unopposed, will change the motion of an object. A force can cause an object with mass to change its velocity, which includes to begin moving from a state of rest, i.e. to accelerate. Force can also be described intuitively as a push or a pull. A force has both magnitude and direction, making it a vector quantity. It is measured in the SI unit, which is the International System of Units of Newtons. So it's measured in newtons. Okay, when standing, what forces are acting on you and what do you feel? So if you're standing up, then obviously you can feel the floor pushing up on you. Now, is this the only force that is acting on you? No, because obviously if it was, then you'd be hurtling upwards, but you're not. So there must be another force involved so that the motion is unchanged, which means the other force is weight, which is pulling you towards the center of the earth. Weight, you feel weight due to gravity. And it is different for each object depending on weight, on the mass. Okay. So I throw a ball vertically upwards. What forces does the ball feel at each point in its journey? So you're throwing the ball up. It's going to A, to B, back to C, back to the same level that it started off at. Now the only force acting on the ball is gravity. Because it's up in the air. We always ignore air resistance. Initial force used to project ball upwards disappears as soon as it leaves your hands. Yeah. So initial force used to project ball disappears as soon as the ball leaves your hand. So you don't draw this initial force on your force diagram. Okay, so two boxes sit on the ground, one on top of the other. Draw each object separately and add the forces that each object feels on your diagram. So this is obviously the system of objects. So the first thing we need to draw is obviously the ground that everything sits on. Then you have the bottom box. And then you have the top box. Okay, what is the ground feeling? The ground feels the bottom box because it's only got contact with the bottom box. It feels the bottom box pushing down. What does the bottom box feel? The bottom box feels the weight of weight. So its own weight. It also feels the top box pushing it down. Plus top box pushing down. And it also feels the ground pushing up because it's got contact with the ground pushes up. Now, what does the top box feel? The top box feels its own weight. So weight of top box. I should have written weight of bottom box. Plus, nothing plus here. Plus, it'll feel the bottom box pushing up. So that would be the force diagrams written in words, described in words. So when two objects come into contact with each other, each exerts a force on the other object. The direction of the force is perpendicular to the surface of contact, so the reaction force is sometimes called the normal reaction force. So if you want to talk about this one, if I wanted to write reaction forces instead, if I go back, so this is bottom box and top box, and this is the ground. Then what I can do is I can write reaction force. This is the reaction force of the bottom box. So I can write reaction force of bottom box. Here I've got weight of bottom box plus the reaction of top box. Here I've got ground pushing up, so reaction with ground. So anytime there's a contact between two objects, there's a reaction force. So reaction with bottom box and weight of top box. And what you do know is these two are the same. And these are two are the same. Okay. Tension is a force that prevents two objects moving away from each other. It is often found in strings and rods. The cross piece in a pair of step ladders is in tension as it prevents the two sides from separating. Tension force is pull. So what you have is normally you can have a tension on a string. So normally there's two parts. So tension is like this. So it's keeping the string from breaking. So it's working the opposite direction of the pull. Or it might be this way, when two things are connected with a string or a rod. Again, they're moving away from each other, so obviously the string or the rod might break. So in order to counteract that, tension is like this. So it's stopping the two sides from separating by acting in the opposite direction. And here, reaction force, it can be the ground, reaction with box, in reaction with ground, so on. Okay, in each of the following situations, draw a diagram to represent each object, labeling clearly the force acting on each object. Okay, so 1, a box. A box falling through the air. So get a box falling through the air. The only thing acting on it is gravity, so it's going to be weight. 2, a box sitting on a table. The table is on horizontal ground. So we've got table, we've got the ground, we've got the table, and then we've got the box. Because the ground feels the reaction with the table. So reaction of table. So the table pushing down. The table feels the weight of the table. Plus it feels the box pushing down. So reaction force of the box. Plus the reaction of the ground. the box feels the weight of the box, and the table pushing up, so the reaction force from the table. 3, a box hanging on the end of a piece of string. Box with string and the string. Okay, so the box feels the weight of the box, and then it feels the tension, which is keeping it up. And the string feels the tension, like so. 4 is a man in a lift. So a man in a lift is, so first we've got the man, then we've got the lift, then the string holding the lift. So what does the man feel? The man feels the weight of the man pushing down, pulling it down, and the reaction force, so the lift pushing it up, so the reaction force from the lift. The lift feels its own weight, so weight, let's call it W. Weight of lift. It also feels the reaction of the man, so the man pushing down on it, so plus the reaction force from the man. And the tension from the string that's holding it up. And the string feels the tension to putting it down. Okay, 5 is a man in a lift standing on a step ladder holding a box, holding on the end of a piece of string. So we've got a box at the end of a string first. So, box with a string. The man who is holding the string, who is standing on a step ladder, which is on a lift, which is held by a string. Okay, so what does the box feel? The box feels the weight of the box and the tension from the string. The man feels the weight of the man plus the tension from holding this box on the string. Plus it feels the step ladder pushing up, so it's the reaction force from the step ladder. The step ladder feels its own weight. Also, it feels the reaction, so the man pushing down on it, so the reaction from the man. It also feels the lift pushing it up, so there's a reaction from the lift. The lift feels its own weight plus the reaction, so the step ladder pushing down on it. It also, because it's held by a string, it also feels the tension holding it up. And the string feels the tension, which is stopping it from breaking. Okay. With another person, do the following. Pull either end of a string. What do you both feel? Can you draw a force diagram? So when you have a string and you are pulling it either end, so this one's pulling this one's pulling this way, that one's pulling this way. What this person feels is the pull from the other person, which is there. And the person on the right hand side feels the other person pulling it that way, even though they're pulling in the opposite direction. So this is called tension. Okay, push either end of a pen. So if you hold a pen and then you push either end, so you're pushing this way and the other person is pushing the other way, then what you feel is this. So the person on the left hand side feels like they're being pushed away, and the person on the right hand side feels they're being pushed back as well. So both of them are feeling like they're pushed back. This is called thrust. So tension is a force that prevents two objects moving away from each other. It is often found in strings. So tension is found in strings and rods. The cross piece in a pair of stepladder is in tension as it prevents the two sides from separating. Tension forces pull. If you look at it, tension is pulling. That pulls the person to the middle. Thrust is a force which prevents two objects coming together. It can be found in a rod, but not in a string or a rope. The legs of a chair provide a thrust force that prevents the seats of the chair falling to the floor. A rod between two objects can provide the thrust force required to keep them apart. A string or rope would just go slack. So thrust forces push. So if you look at it, so these are pull, and these are pushing the person. It is important to remember that strings and ropes can exert only tension forces, whereas rods can exert both. So that's the main thing that you want to take away. Strings and ropes are tension only, and rods can have both. Okay, a box is sat stationary on a table with a piece of string attached to it. So we've got a table with a box on it, with a piece of string on it. The string runs over a frictionless pulley. Okay, and from it hangs another box. So there's another box, something like that. Draw a force diagram for the three objects, the two boxes and the pulley. So first thing is box on table. And then there's the pulley. And then there's the box that's hanging box. What does each one feel? So the box on the table feels its own weight of box on table. It feels thrust, so tension, not thrust, sorry, tension from the string. So I'm just going to write it here. Tension plus you'll feel the reaction force from the table pulling it up. So reaction from table. Okay, the pulley feels tension on either side and it balances it out. That's why it doesn't move. So tension on either side. The hanging box feels the weight of hanging box, and it also feels tension. Okay, next question. A train has its engine at the rear. So let's say engine here. At the back, the engine is connected to a carriage by an extensible metal rod. The driver says carriage. The driver is attempting to get the train to move, but the carriage is too heavy. Draw a force diagram for the two objects. Okay, so we have the engine. On the carriage. Okay, so because it's stopping, the engine and carriage are being stopped from colliding, there is thrust involved. So thrust, it works in the opposite direction. So it's a pushing force. So that means thrust is in this direction and this direction. Okay. it feels the weight of the engine, weight of engine, and weight of carriage. The drivers attempted to get the train to move, but the carriage is too heavy. Because the carriage is heavy, there must be a full friction stopping it from moving. So friction must be acting in the opposite direction. Friction, and there must be force that's driving it forward, which is the force. So on. Okay. So what is a force diagram? So in this obviously topic we learned about force diagram. It consists of a simplified representation of the object. So draw it as simply as you can. Forces shows straight arrows pointing in the direction they act on the body. By convention, all arrows shown act away from the object, e.g. push force will be represented as coming out of the box. So like this. Note, large diagrams are key, so always draw large diagrams to complete the question. The length of the force arrow does not represent its magnitude. Only forces that are acting on the object should be represented on the force diagram. Internal forces should not be drawn. Objects should be separated unless you're ignoring internal forces. If you want to draw a force diagram for the whole system, be warned that later in the question, you might have to draw different parts of the system separately. So it's best to draw it separately.